Good morning. I want to thank you again for joining me this morning. I'm Professor Tom Goulding, Professor of Computer Science at Daniel Webster College in Nashua, New Hampshire. And in this tape I'm going to begin our discussion of the technology demonstrations, which are a very important part of mastering technology necessary for a freshman to build a full client-server casino system. This is part of what we call the roadmap, if you will, to success, to be able to develop the kind of knowledge that you need in order to be able to build a full and complex piece of casino software. Today I want to talk a little bit about how those technology demos actually begin. Good morning. I want to thank you for joining me this morning. My name is Tom Goulding. I'm a professor of computer science at Daniel Webster College. And I want to talk to you this morning about the technology demos, which are a very important part of the G method of software development that we use at Daniel Webster College, especially the method that we use with freshmen or novice programmers. If you recall from some of my other tapes, that in the CS2 course, or the second term of the freshman year, the students have only done console programming for about 14 weeks. So basically they're really novice programmers and they have no experience in event-driven operating systems, Windows programming, or in the .NET framework. And yet in the second term of the course, or the second term of the year, we ask our students to develop a full multi-client, multi-game, client-server casino system, including backroom control of the clients as well as player accounting. An important part of being able to achieve that goal in 14 weeks with a novice is that you need to lay out a roadmap for the students of what kinds of technologies that they need to master in order to ultimately put together a full casino system. And we have articulated 8 technology demonstrations for our students that once they master these technologies, we believe that they have all of the tools necessary in order to build a full client-server system. So this morning I want to talk to you about the first technology demo, which is really quite simple. Except keeping in mind that the students have never put any kind of an image up on a window. So the first technology demonstration, which they see in the first day of class, is that they have to build something that simulates, if you will, looking at a crap table. They have to put a crap table up on a window. We're going to be asking them to do some logins. We're going to be asking them to do some minor changes of some labels or some messages that are displayed on the window, and then we want them to cycle through a directory and show us a variety of different dice. And I will give you in a moment a demonstration of this technology demo. Some important things to keep in mind with our technology demos is that the students get an executable which they can download to their own computer and they can run it as many times as they like. However, one of the secrets of high performance or massive knowledge assimilation, which is necessary to be able to do this kind of thing in 14 weeks, is that we do not lecture our students on the technology, nor do we provide code solutions for our students whatsoever. Students are required to study, research, and independently master whatever technologies are necessary in order to build an executable that is similar to the one that they've been called upon to demonstrate. So the students work in small teams of about 3 or 4 students, and their goal each week is to master the technologies necessary so that each of them can write the code to be able to do the kinds of things that I'm going to now display. So this is a reasonably easy technology demo. We give them some radio buttons that we ask them to put on a form. They need to log in, and we ask them to demonstrate that it'll only accept the correct login. In this particular case, if I were to enter the number 6 into the technology demo, you'll notice that it comes up with an invalid ID and tells me that the only valid IDs are between 1 and 3. It'll also handle correctly if I were to put in a non-numeric value. It will also come up with the same error message and tell me that it requires 1, 2, or 3. So the students can run this demonstration as many times as they like in order to completely understand what it is that they're required to do. You notice that once there is a successful login, we do ask our students that they display a message, login successful, good luck, somewhat simulating what a casino might display for one of its players. He's demonstrating that he's recognizes this particular player, and this player has a particular identity, or what they might call in a gaming casino, a handle for himself. Another aspect of this demonstration was to be able to change the greeting by clicking on a button, to be able to change it in both color and in terms of italics. Just another nice little feature that would have them demonstrate, not very complicated. And then finally, to be able to click on a button and to be able to cycle through a directory showing a variety of different dies. So a reasonably modest technology demo, even for students who have done no Windows programming, have no experience with .NET, know nothing about object-oriented programming whatsoever, have never looked at a properties windows, don't understand object-oriented methods, etc. But we send them off using two very good texts as references, as well as, of course, they can go off and do a lot of research on the World Wide Web. And most students and most teams will be able to master this technology usually within 1 3-hour laboratory period, but certainly within 1 full week, which would include 3 lecture hours plus 3 laboratory hours. And finally, in closing, let me mention that those lecture hours in our class are no longer used for lectures. Those are also laboratory hours where the students are working completely on their own, trying to understand and master the technology to be able to do this technology demonstration. In another tape, I will show you a companion document that I also provide the students that goes along with the technology demonstration, which is what in industry one might call a work breakdown structure. Here I might call it a task assignment checkoff list, which actually is a written description of the functionality that they must achieve, and it has a place on it for approving or checking off that it was accomplished, and signatures for the professor to initialize, and that becomes part of the assessment system of the students on a week-to-week basis. Thank you for joining me again today.